Okay, so the key to doing this limit problem is plugging in the x plus h in the place of the x. Okay, that seems like a little bit of a jump sometimes for people, but basically what we're going to do is we're going to say the limit as h approaches 0 of f of x plus h. So I plug in x plus h where I see the x. So there I see the x right there, and I plug in x plus h for the x. Alright. Then I say minus the plain old f of x, which is 1 over x plus 2 over h. Okay, so that's what that looks like. And now I have to get a common denominator. And the only thing I know to do is multiply by the least common denominator, which is x plus 2 and x plus h plus 2. Okay? That's my least common denominator. When I don't know, what they are, I just have to use both of them. And same thing on the bottom. Do I really need the 1? I don't think I need the 1. It's over 1. Okay? And so here we go. On the first fraction, the second part cancels, and I'm left with x plus 2. On the second part, and I better use brackets because there's a negative sign out there, the x plus 2 cancels, and I'm left with x plus h plus 2. And it's all over h times this stuff. Nothing cancels. Okay, well, what happens? Well, when I distribute the negative sign, notice that everything inside changes. So I get, let's use this color. We'll say x plus 2 minus h, minus x, then minus h, and then minus 2 over my common denominator, okay? So it's still the same, hasn't changed. Well, I don't know if you noticed it, just about everything leaves as a result of that, and I get negative h over h. This is my common denominator, hasn't changed. And the h's cancel. Alright? So I'm left with negative 1 over my common denominator here. And as h approaches 0 here, so I can say, well, how much do I want to say? The limit as h approaches 0 for negative 1 over x plus 2, x plus h plus 2 is equal to negative 1 over, it's just x plus 2 squared, right? Because the h just drops out at 0. And that's my limit. You say, but there's an x in it. Well, it's okay. That's what we get. And then moving on, solving exponential equations, basically it comes down to taking either the log of something or the natural log of base e, obviously, of both sides. Take the log of both sides. Sometimes you don't need to do that. Of course, you can always check it graphically. Sometimes it's just good old common sense. You can see the answer here, but let me show you how I got it. I divide both sides by 6, and I get 10 to the x is equal to 36. 216 divided by 6 is 36. And then I take the log of both sides. I say log, that's base 10. Do I need to write the 10? I really do not need to. I assume it's 10 if I don't, but anyway, I'll write it anyway. So what that's saying is I'm going to raise 10 to whatever's required to make 36. and I say, well, I don't know what that is. So it's not a nice, easy number, so I just say, that's my answer. And that's it. Okay? Because I know on this side, this side, what do I have to raise 10 to get 10 to the x? Well, the answer is x. So this side is x, and it equals, that. So I solve for x. Okay, there we go. And if I have a calculator, then I can tell you what that is. But, I'm happy with that. Okay, fine. 36. What is it? It's 1.5563. Fine, doesn't matter. Oops, didn't mean to do that. Let's go down here. This makes it a little bit more normal. If I'm going to use the log base 2 this time. Now I better write the 2, because if I don't, I assume it's 10. The log base 2 of x to the x plus 3 is equal to, I got to take the log base 2 of the other side. Same thing to both sides, right? Okay, well, if I say my base is 2 and I'm raising 2 to something, what is that something? Well, it's just what it is, x plus 3. It gets rid of the base when I do that. And then, you can do this on your calculator. You can figure out how many 2's are in 256, and you will find out, if you want to do the change of base, that'd be, let's just use natural log. Natural log of 256 over the natural log of the base I don't want, 2. And when you do that, you're going to get 8. Okay, because there's 8 times. 2 times 2 times 2. 8 times is 256. And now all I have to do is subtract 3 from both sides. And you can see how I got 5. X is equal, as it says here, x is equal to 5. All right, but it started with taking the log of the base I didn't want, so I could get rid of that base and just take the exponent. Okay. That kind of exposes the exponent. That's the trick.